Math 113, Lesson 10.3, we're going to cover the parabola. So we've actually covered parabolas before, and these are the equations that we're used to seeing. Not something new. We covered this in Math 112, if you took 112, or in whatever pre-cal class you had before now. That may have been high school. So both of these are equations that we've worked with for a parabola. In this first equation, our vertex is the ordered pair h and k. For this second equation, this quadratic equation, in order to find the vertex, you start with the x coordinate, negative b over 2a. Well, to find the y coordinate, you have to plug that x value in to our equation. So let's say we say the function at that x value. That just means plug it in, you'll get a y value. For both of these, if a is positive, then it opens upward. If a is negative, then it opens downward. So this is just a review of things you already have heard about parabolas. So that's really old news. So let's move on to parabolas in Math 113. It's similar, very, very similar. All right, and so we're going to look at our parabola like this. Now I'm going to slide this back down so you can see just how similar it is to this equation right above. Let me see if I can't point out the similarities for you. All right, so here's the x minus h squared. If I took this k and moved it over here with the y, there it is, y minus k. All right, I left something off in this equation. There should be a p right here. All right, and so the only other thing that we have is this a value and 4p. So these two equations are really the same equation, just rearranged in a little bit different order. And instead of a, it says 4p. Okay, so you may or may not even care if I showed you how it related to that. All right, so here's our equation. All parabolas have a vertex. Our vertex is the ordered pair hk. Notice that in my equation here, it says minus h and minus k. In the vertex, it says positive h and positive k. That is not a mistake, so you are going to take the opposite sign. All right. P, let's just talk about what P is. P is the distance between the vertex of our parabola and the focus. Now, when we've done parabolas before, we didn't have a focus. Well, now we are going to have a focus. We are also going to have something called a directrix. And the vertex is midway between the directrix and the focus. All right, so let me just draw what this parabola will look like. Now, this particular parabola, because the h and x value, okay, because this is the thing that is squared, the x value is what is squared, that means that it is going to open up or down. Our directrix is going to be horizontal. So this particular graph is going to either open upward or downward. One or the other. Hyperbola is two curves, parabola is just one curve. So this particular one let's say that I just look at one that my vertex is at the origin for the moment. Your directrix is a line. Okay, your directrix is a line. The vertex is midway between the directrix and the focus. Okay, when we did parabolas before, we had an axis of symmetry. So imagine right now our y-axis is our axis of symmetry, and that is perpendicular to the directrix. All right? The distance from our focus to our directrix, from our focus to our vertex is P. The distance from our vertex to our directrix is P. Okay, the distance between those is P. All right. We do have another equation for a parabola because I said that this parabola either opens upward or downward. Well, guess what? There are other parabolas that maybe you didn't even know existed, and they don't open up and down, they open left and right. All right, so the y value is being squared, so these parabolas open left or right. Not both, it's just one curve, right? And it depends on whatever the p value is. If p is positive on this first equation, then it opens upward. If p is negative, it opens downward. A lot like the a value was originally in parabolas that we learned. Over here, on the second one, what opens left or right, if our p value is negative, it opens to the left. If our p value is positive, it opens to the right. And for both of them, my vertex is H and K. And for both of them, P is the distance from the vertex to the focus and from the focus to the from the vertex to the directrix. So this graph right here goes with that equation. All right. So I'm going to slide this over. And I'm going to slide it up so that you can only see this equation. All right. And I'm going to draw a graph that looks like that. I'll draw this one in purple. So let's say we have our parabola that looks like this. Here's my vertex. Here's my focus. My directrix is a line perpendicular to the axis of symmetry. The distance from the vertex to the focus is P. The distance from the directrix to the vertex is also P. This line is my directrix. It is an equation. In this case, it's a vertical line. Now, the one I have graphed for you is opening to the right, so this is one where the P value is positive. All right, so let's try one. Let's try a parabola. So, got all this information in front of you. Let's see what we can do with it. We are going to find the focus. There's just one focus this time because there's only one curve. And we're going to find the directrix. Okay, we're going to find the focus and we're going to find the directrix. Our equation is y squared equals 8x. Oh wow, that looks slightly different than those equations that I just wrote for you. Well, the thing that I do notice is that the y part is squared. So this is the equation that this relates to. Okay, the y part is squared. The y is squared. So this is the equation that we're looking at. It just looks like we're missing a whole bunch of stuff. All right, they did not ask for the center, but we are going to give it. All right. Now, in this particular equation, we don't see an h or a k. So that means our center is 0, 0. All right. The next thing I need to know is what is P. That way I know if it opens upward or downward, and if it's positive or negative, it tells me if it opens, left or right or up or down or which way it opens and all that good stuff. So since the y is being squared, this thing either opens to the left or it opens to the right. Remember, if P is negative, it'll go to the left. If P is positive, it'll go to the right. So let's find P so we know. Well, in our equation, 4P is sitting in front of the x. The thing in front of our x is 8. So 4P is 8. That doesn't mean P is 8. 4P is 8. So divide by 4, and we get P is 2. Okay, awesome. We got P is 2, which is a positive number. Ours is definitely opening to the right. Okay, ours is definitely opening to the right. Now, they didn't ask me to graph it, but the reason that's helpful, let me go back to black. The reason that that's helpful, I've just decided that my vertex is here. I called it a center. I'm sorry, it's a vertex. My vertex is at 0, 0. And I have decided that it opens to the right. Now, the reason that's helpful for me is I know that my focus is somewhere inside the curve, and I know my directrix is out here running perpendicular to the axis of symmetry. All right? And the distance from the vertex to the foci is 2 spaces. And the distance from the vertex to the directrix is 2 spaces. So that helps me answer the question for foci and for directrix. For focus and directrix. So my focus, we already decided our vertex was at 0, 0. So we go 2 spaces to the right. So my focus is 2, 0. My directrix, I've already decided I'm going to go 2 spaces to the left, and that's going to put me at this line. Your directrix is not a point. Your directrix is a line. It is a vertical line at x equals, in this case, x equals -2. Because remember, we went 2 spaces to the left, and that put me at an x value of -2. Not an ordered pair, that's an entire line. X equals -2. So there we go. We were asked to find our focus and our directrix. There they are. Now, if they had asked me to graph this, what I did over here for a graph is not acceptable. Just so you know. Let's do one where we do have to graph it. So we're still finding the focus and the directrix here, and we're also graphing this one. All right, so I've got an x squared. So I'm going to write down that original formula. All right, there it is. So I've got an x squared. When the x is squared, this thing either opens upward or it opens downward based on whatever the value of p is. If p is positive, it opens upward. If it's negative, it opens downward. Just reminding you. All right, so in my equation that's sitting there, -12 is 4p. All right. So divide by 4 and we get -3. All right, so p is negative. So this is definitely opening downward. Definitely opening downward. All right, let's look at what our vertex is. H and K, it doesn't appear that I have an H and K. They are 0, 0. All right, so here's my vertex. All right, there's my vertex. I've already decided that this thing opens downward. Now, I can't just draw a curve because I don't know how fat it is. All right, I don't know how fat this curve is. So the next thing I'm going to find is I do need to locate the focus. It asks for that. I do need to locate the directrix. It asks for that. And then we'll worry about finishing up our graph. All right. Remember, our focus is P spaces from the vertex. And this opens downward. All right. It opens downward. So let me just draw that in like a green just so we can see why that's important. All right, if it opens downward, my focus is inside, right? My focus is inside. So our vertex over here is at 0, 0. So we need to go P spaces down. So that's going to put me right here. That's going to be my focus. Here's my vertex. Here's my focus. That is the order pair 0, -3. My directrix is on the other side of the vertex, and it is perpendicular to the axis of symmetry. All right, so this would be my directrix, and that is a horizontal line at y equals 3. Not a point, it is a line. Now, again, we still can't just draw a curve, okay, because I don't know how fat this curve is, and since they asked me to graph it, I do need to be a little bit more precise than just sketching any old graph, right? So what I'm going to do is I'm going to say, you know what, I'm going to pick a point, and I am going to help you decide what point to pick. All right? We are going to pick points above and below, in this case, to the right and to the left of the focus. All right? We're going to pick points to the right and to the left of our focus right here. Because here's why. I know my curve, so I'm going to have to erase this because it's not going to be correct. I know my curve looks something like this. And so there's a point here and a point here in line with that focus, right? Which means my y value is -3 on both of those. If I knew what this point was and this point was, I could have a really good graph. Well, I don't know if it's that skinny, so I need to erase it. All right. That was my vertex. Okay, so I'm going to take my equation. Remember, my original equation was x squared equals -12y. And I am going to plug in -3 where there's a y value. The same thing as my focus, -3. I get 36. Oh, when I square root that, I get plus or minus 6. So I get these two ordered pairs. Okay, so I'm going to need to add one right here. So 6, -3, and -6, -3. Yeah, the one I sketched was really wrong. It was a whole lot fatter than what I expected. So when you graph a parabola in my math lab, they are going to ask you to graph some other points. Choose points that are in line with the focus, and that will be helpful. So this would be a really, really good graph for us. Let's try another. All right, this time we're looking for the standard form of the equation of a parabola with a focus at 8, 0 and directrix x equals -8. Okay? So we want the equation. Now, even though they're not asking for the graph, it is helpful to sketch what is given to us. All right, I am given the ordered pair 8, 0. Okay, so let's say that this is 8. So this would be 8, 0, and that is my focus. All right, my directrix is x equals -8. That's not a point, that is a line, a vertical line. X equals some number is a vertical line. I know that my vertex is midway between the focus and the directrix. So that would put my vertex right there. It's in the middle of the focus and the directrix. So my vertex is 0, 0. Remember, your p-value is the distance from your vertex to your focus. So it would be 8. And for sure, this one opens to the right. All right, so that would help me choose my equation. Now I know it's opening to the right, so it's definitely a y squared. And now I'll plug in everything that I know. I know my center, not my center, my vertex. I know my p-value. Now, one thing I want to point out to you, it's opening to the right, so p is +8. If it opened to the left, p would be -8. All right, y minus 0 is just y, so we have y squared equals 32. X minus 0 is just x. So y squared equals 32x. There's our equation. And we're done. Okay, let's do one more. Let me make sure. Yeah, one more. And we are done. All right, this time we are going to find the vertex, the focus, and directrix. Not asking you to graph it, however, a sketch might be helpful. All right, so here's our equation, and I'm asking you to find the vertex, the focus, and the directrix. All right. First thing I know is that x is squared. When x is squared, it either opens upward or downward. So it's one of these two. If p is positive, I know it's the one opening upward. If p is negative, I know it's the one opening downward. So let's find p. All right, so 4p is 4. So divide by 4, and I get my p-value is 1, which is positive. This one definitely opens upward. Awesome. So I know for sure it opens upward. That's going to help. Now let's talk about our vertex. That one's kind of easy to find looking at our equation. My h value is with the x. Take the opposite sign, so we take 2. My k value is with the y. Take the opposite sign, so it's -1. All right, my focus. All right, so let's say this is my little parabola here. Here's my vertex at 2, -1. All right, there's my vertex. Might be helpful for you guys if I had an x and y axis. Okay, not a very accurate graph, but that does represent my vertex on that graph. So 2, -1. All right, so my focus, remember your focus is inside the curve, okay? So my focus is somewhere in here, okay? I don't really know where, but it's somewhere inside my curve, and it's on the same line as the axis of symmetry, so it's in line with the vertex. Remember, your focus is P spaces from your vertex. So I drew it in the wrong spot. Okay, I drew it way up there. It's not going to be way up there because remember, it's only one space. Okay, if this is my vertex, my P value is 1. I go one space up, and that's where my focus is. Right, one space up would be my focus. So if I went one space up, that's the ordered pair 2, 0. My directrix goes the other direction. It's on the outside of the curve, and it's not a point, it's a line. So there would be my directrix, remember, one space away from the vertex. So my directrix is the line y equals -2. It does have to say y equals -2. So we have found the vertex, the focus, and the directrix. So we have done everything it asked me to do. So be careful as you're doing these. Make sure you have all your equations beside you. If you have any questions, please let me know. I'd be glad to help you. Email me with any questions you may have.